Morning, everyone. So yeah, about me, I've been in the industry for about 15 years, various other bits and pieces. Obviously moved to Perth because I love skiing. So just straight into this. So what's this all about? So quick show of hands, who's actually heard of IPFS? Yep, that's pretty much where I was too. So I went to the interview with BitCar. BitCar are a small startup based in Perth. And one of the first challenges that I was pitched was, we want to make this completely decentralized. And to do that, we're going to use this thing called IPFS. And I went, yeah, I've used that before. Good? Yeah. So the aim of this is, I guess, to provide a link between the Ethereum blockchain, which we'll be using for our backend, and then a front-end system there. So I guess in terms of why the business wanted to go in that direction, predominantly it was because we wanted to create that sort of fully decentralized application. The dApps of the blockchain world, trying to stop the centralization of servers and various other bits and pieces. Our managing director wasn't keen on that, sort of using centralized systems. We also had the security of the hashing. So the concept is that with the hash algorithms used in IPFS, the content's always stable, and you can link that back to the blockchain. We also had, I guess, the speed of the global network from an IPFS perspective was meant to be there. And it's the future internet, right? That's what we were told. That's what we were trying to be pitching. So we wanted to use it for our future app. So what exactly is it? So I guess from a peer-to-peer protocol perspective, it's a bit like any sort of peer-to-peer network. The idea is that all multiple nodes are hosting the content, and they're all sharing that content applicably, okay? The other thing is it's a distributed file system, so a bit like the Git repository. You check stuff in. It's a distributed system like that. And we've also got the design to overcome some of the HTTP limitations. So traditionally with HTTP, you've got sort of a centralized point of contact. Obviously, you can use distributed cloud systems to try and get over those limitations. But the concept is, with IPFS, that every node on the network, in theory, can deliver that content from wherever you are. The other thing is it's a truly decentralized context. So the idea is that you haven't got decentralized servers. All the content's hosted on all these nodes, and everyone's able to utilize that content. So if we look at this diagram, pretty simple. You've got all the nodes connecting to a central server. Obviously, that could be distributed over geolocations, various other cloud technologies. But the idea of IPFS is all the nodes are able to communicate together at all times and able to get your content from there. So I guess, how does the hashing work? So hashing is core to IPFS. The idea behind it is similar to GitHub. When you check something in, that content has a unique hash. You can always get back to that content. So the idea is it's a versioning system, and you know that content hasn't been tampered with. So a very clever person, far cleverer than me, called Ralph Merkle, came up with the concept of Merkle trees and using hash content like that. So the idea is that you have a various content that gets distributed across the system. It gets encoded and encrypted, and a hash is created from that. And then that creates like a tree of data, which I'll show a slide on to explain it a bit better. And it's a cryptographic hash. So the concept is that hash cannot actually be recreated if that data changes. So as soon as any byte of data changes in the content that you've uploaded, that will have a completely different hash to something else. So the idea of that is obviously to get away from criminal sort of activity or the censorship or people actually modifying content. You always know that you've always got the same content that was originally uploaded to that hash. The other concept as well, each file is effectively broken down in 256 kilobyte chunks, and then all those chunks are put together to produce an overall hash. And that's the concept of a tree. So at the very top of the tree, you have your sort of principal hash, and that's broken up of all the other 256 kilobyte chunks of those particular files. And this is the hash tree, or the Merkle tree. So we wouldn't be in Australia without a picture of a koala, who's obviously very happy about using hashing and Merkle trees. So some very simple IPFS commands. You've got to run the daemon locally. It's IPFS daemon after you've set up and installed it. And being a Windows person, I'm obviously using subsystem Linux on here. And you just literally just add a file by calling IPFS add and the file name, and that creates a hash, which you can see there. That hash for the first file, because the file's only 81 kilobytes, that's the only hash that gets created. So for the bigger image, you've got a 1.31 meg file there. It's broken down into all the hash sizes, and you can see it's around 256K. And each one of those hashes forms the top level hash that you can see up there. And that is the concept of the tree. So our nice cuddly koala is broken down into that top level hash, which is actually formulated by hashing all of the other hashes that are created from that. Okay. So some use cases. Now, although we were using it at BitCar for production purposes, what actually ended up happening was we had to have a centralized node running IPFS to actually host our data. Now, one of the limitations with IPFS at the moment is your data can effectively disappear over time. So unlike a centralized server where you host it yourself, you know it's there, you know it's always going to be there unless you delete it or the server goes down. With IPFS, it's up to the nodes to decide how long that content stays there for. So unless you have your own node hosting your own data content, in theory, your data could disappear. Now, in practice, whether that could happen, it depends on how often people are accessing that data and how often you're actually updating and making sure that content's actually getting hit. Repositories, so you could use it for version control, things like that. You can also use it for remote working. So if you need to have sort of general access to things and you don't want to expose systems, you could use it for that. Documentation, things like that. The thing to bear in mind is obviously it's completely public. So you don't want to store private keys on there, you don't want to store anything like that. And if you're going to use it for websites like we did, you have to make sure that you're not using anything that could potentially get onto the public infrastructure. You've got to assume that your entire server is open to anyone. So it's a very different way of working from a security perspective. It's like just having an open node and everyone's got access to that data. So I thought, I've gone through a lot of things very quickly, I understand that. And I wanted to go into, I guess, a bit of a demo to sort of show how that's going to work. I don't know how well this is going to go, so we'll see. So I'll get started with this. All right, can everyone see that all right? Yeah, cool. I don't know how much it's going to jump around, so we'll see how we go. Let's just start our daemon. So what it's doing at the moment when it kicks up, I've set it up to appear in a swarm. So the idea is that my actual node that's starting here, you see it's listening on various IPs and ports, and the swarm announcing that it's there. So what's happening now is all the other nodes in the IPFS infrastructure are now starting to communicate with my own node, and I've become part of that swarm that exists in the public domain. And now I've got a local server that's listening as well on port 8080. And so if I jump across to something I prepared earlier, we can actually have a look at our, where's the mouse? There we go. Right, so that's running off IPFS. And there's a hash at the very, very top. But one of the things I wanted to show as well is obviously the concept of running an actual entire web application. So what I've done is just do a very basic create React app. Which I'll show you here. Push that up. So as you can see, you've got your standard sort of file system here, code source, images, style. I've added a few extra folders just to make it, to show that you can actually distribute an entire folder structure to IPFS and then have it run. And I've done a build of this already. Let's just see, I think this wasn't working before. Let's just do, there we go. Let's do that one. Okay, so, very quick little script there. The code here was pretty simple. So using the Infura, I tried doing this earlier, it didn't work because of the ports and the Wi-Fi, but what I've done is connect to my local host. And all we've done is use our IPFS HTTP client here. And the idea is that with the host and the port that we've added, we just do an add from file system, and it's iterating through the entire folder structure. Now you notice there's a flag there called pin. Now, pinning in IPFS is kind of crucial. If you don't flag pin, the chance of your data disappearing quickly is high. The idea of pinning to an actual node means that node, in theory, shouldn't be deleting your data. So when you pin your actual data, it's more likely it's going to linger for longer. If it's your own node, it means it's going to stay there. And other nodes will start picking that up. So if we just have a quick look at what that looks like. So if I go here, this is our latency logo, actually hosted in IPFS in Infura. So you can actually go to that URL. So if everyone's together the phone and start typing that in, no? No? No takers? No? All right, so this is the other issue with IPFS. So DNS we rely on pretty heavily nowadays. No one likes typing in IP addresses and no one can remember them anyway. But this is even harder. Obviously the hash key there is incredibly hard to remember. We got around that issue with BitCar using a product called Rebrandly. Has anyone heard of Rebrandly? No one. Wow, oh, okay, awesome. Rebrandly is like a redirection service. So the idea is you sign up and you can actually pull your links in, a bit like tiny links and things like that, but you can actually name them yourself. You can actually host your own domain there. And the reason we went there is being a startup, obviously costs are a limiting factor, it's free. So that was a big plus. And you can basically go in and just choose whatever you want. So if I just log in to Rebrandly, sorry. Now you can use other things as well. IPFS supports an IPNS as well, which is Inter-Planetary File System sort of naming protocol. And the idea is you can actually pin content to a fixed hash in IPFS. And that fixed hash will never change, so that your content always links back to that. And when you release new content to other hashes, you can actually then pin it back. Okay? The downside to that is the time. I mean, if you think about sort of engagement in terms of user experience, most people expect a website to be loading pretty snappily, like within sort of 5-10 seconds. How does 1 minute 30 sound, people? 2 minutes? No response generally is what happens as well. We tried moving to IPNS probably about 3 months before I left BitCar, and after we basically just ran a local trial of various IPNS hosting providers, Cloudflare, Infura, some of the big ones. Average turnaround was, I think the best time we got was 45 seconds. And then you hit refresh, and then it would jump back up to 1 minute 30. So not great. The other way around it is to use DNS text links. So you can actually go into sort of DNS provider, and you can provide TXT key pairings that actually tells the DNS provider where your hash is. Downside to that is obviously then you've got distribution if your hash changes. So you can never get around this sort of centralized issue with IPFS at the moment, as much as they're trying to. No one really knows why IPNS is so slow either. There's some theories around the fact that the IPNS provider is linking back to your own node. So when you actually deploy using IPNS, your hash gets distributed to multiple nodes. So for example, the Infura node and Cloudflare nodes would pick up your hash. But the problem is it needs to verify that that IPNS is the same version as all the others. So some theories are that it's actually querying all the nodes in the Infura infrastructure, as well as all the Cloudflare infrastructure, as well as all the other infrastructures, and then it's taking a sort of cross-compare of about 10 or 15, 20, and then deciding whether or not that's correct. But because the infrastructure is relatively slow still, there's not a lot of uptake. The IPFS economy is pretty low. It's just causing a lot of delays that no one can really deal with. So sorry, I'm sidetracking onto here. But so what I can do in here is I can do a new link. Let's punch in our URL that we had here for Infura. And let's just call this latency 2019, as I'm sure no one's done that yet, as none of you have heard of it. So if you now go to rebrand.ly/latency 2019, you should actually be able to see the exact same site that I can bring up. If I've punched the right URL in. Yep. So you should be able to get to the latency 2019 logo using that URL there, rebrand.ly. Let's just see if that does actually work. Now I've said it will. Yep, cool. So it just creates like a redirect. So from my perspective, I'd never heard of Rebrandly. From a tooling perspective, it's really powerful as well. That was one of the key takeaways from sort of dealing with some of this. You can actually use your own web hosting as well. So you could have, like we did with BitCar.io. So we had production.bitcar.io, we had various other bits and pieces, and it allowed us to hot link into our IPFS context. A lot quicker to go into Rebrandly and change the hash every time you do a deploy. There's an API for Rebrandly, so we could actually build that into our CI/CD pipeline as well. So every time we did a deploy, we just had a red-green scenario where we flipped between production and current code output. So I know I'm running short on time now, so I'm just going to run into the more complex scenario that we did. So if I jump into the Infura link here, so this is the entire React app running from an Infura node. And let's just bring up. And then the same thing in Cloudflare. So you can see the two nodes are talking to each other, and that's actually come from my initial node deploy. So I deployed to my node, and then all the other nodes are starting to pick up on those changes that have occurred in the IPFS infrastructure, and I'll start pulling that data in. The other thing I did was actually pin it directly to Infura node, because Infura is such a big node in the IPFS infrastructure, the other nodes will start pinning some of that content as well. In terms of what that looks like from a networking perspective, let me get this over there. No, not going to be able. No, sorry, one sec. That's better. Well, we can see that. You see there that initial call that's happening to our hash. And then, so that very top line is our initial call to the hash. And then the hash is basically the index.html of the React app that then is calling out into the various chunks and various other parts of the app that was built. So the actual deployment structure, there was a cool little tool I actually found last night when I was playing around with this that's called PND. So this shows effectively the Merkle tree of the entire deployed application. I'll just zoom in on that for you. If you can see that. So you can see we've got all the files that actually make up that application and their various hashes. And then you've got your root hash, which is actually our deployed hash. And that will be the top of the tree here, with each one of those files effectively in the folder structure forming part of the Merkle tree. If you had large images and things like that were hosted, then that will actually cascade down as well into multiple tree levels. All right. Okay. I think I don't go too bad. So yes, like we talked about, some of the other bits, hash is great, but it's not user-friendly. You can get around it. IPNS takes forever. Like, I thought there was something wrong with our networking infrastructure when we were testing it. That's how bad it is. Security, security, security. You have to think that first. Everything is public. You have to pin things. The distribution lag is a problem, and the IPFS economy is just not there yet. It's still growing. Probably not very quickly. I just wouldn't be able to suggest that you can use this for production when files can disappear. It's just kind of not a good thing for users. But the key learnings, it's a great emerging technology. Bearing in mind it came out in February 2015. It's an open source project. It's getting a lot of uptake still. There's still a lot there. There's a lot of things happening in the world that are sort of pushing it that way with censorship and various other bits and pieces as well. We found it a really useful tool internally. If you want to quickly deploy web applications, part of your CI/CD, you haven't got to worry about a server infrastructure, you just have to worry about a node. And you can have a private node if you want, and you can get back to any of those deployed sites that you've got just from the hash, which is really handy. And you can overcome the IPNS issues with Rebrandly, Cloudflare DNS, DNS link. Again, that adds that centralized point. So thank you very much, everyone. I know that was a whittle through IPFS, and there's lots of complexities there. Has anyone got any questions that I might or might not be able to answer?
All right, can we have a round of applause for Will?